Simultaneous equations, two techniques. What are they? Elimination and? What's the difference? Well, that's a resounding area of improvement. What's the difference? In both scenarios, how many equations do I need? I need at least two equations, correct? How many unknowns do I need? I need two unknowns to use simultaneous equations. So I might have y equals x plus 6 and I've got 2y minus x equals 15. What do I do? In this scenario, I've got equation 1 and equation 2. I would write sub 1 into 2. And in equation 2, everywhere I see y, what do I replace it with? X plus 6. So equation 2 would become 2. X plus 6 minus x equals 15. I'd expand 2x plus 12 minus x equals 15. X equals 3. Am I done? I now need to know what my y value is. So sub x equals 3 into, does it matter? Doesn't matter which one. I would sub it into 1. Y equals 3 plus 6, which equals 9. What technique have I just used? Substitution. You'll never guess how that works. What's that word? If you're writing that word, what does it tell you? You're using substitution. With elimination, I will take that down. You'll get a chance to look at it. With elimination, I'll have two equations up here. I can use substitution at any point in time. I can probably use elimination at any point in time. I won't write that. So if that's equation 1 and that's equation 2, what could I do for elimination? What am I trying to get with elimination? I'm trying to get the coefficients of one of the variables to be the same so they cancel out. So I look at equation 1 and I look at equation 2 and I think if I just times equation 2 by 3, the y's will cancel out. So I would write 3 times 2 minus 1. 3y plus 9x equals 45 minus 3y plus 2x equals 10. 3y minus 3y. 9x minus, that's 0. 9x minus 2. 7x. 45 minus 10. 35. X equals 5. Am I done? Sub that into one of my equations, correct? That's the difference between elimination and substitution. Both are viable methods. I don't care which method you use. Sweet. We've done sketching linear functions, we've done that, we've done simultaneous equations, we've done solving and factorising, we've done sketching. The last two. The most important thing I taught you was right back in week 1 and 2. Both very similar. What's the process for rearranging? We've used it over and over and over again, so it's a really good point to finish on. Opposite operation, how do we go about what's the way in which we attack the problem we use? Reverse BOMDAS, correct? Reverse BOMDAS, opposite operation. In both of these scenarios, what are we trying to get? A variable or an unknown, what do we want it to be? By itself on the top. What's the difference between an equation and an inequality? One of those is an inequality. Which one? The bottom one or the top one? Who thinks the bottom one's the inequality? So what are the inequalities? They got our crocodiles, correct? If we need to sketch them, all we need to remember is that equals means coloured in That's our open circle. Probably should have just done that at the start of the term and you guys would be right, hey? If I'd just gone through the course in 20 minutes, you'd be fine.
Yeah.
So my advice, that's a really quick summary of what we've done. Obviously there's a bit more depth to it, but that's all the topics. If you understood and flowed along with everything that was done then you can do a general bit of revision. If you found there was an area you thought, oh, a bit lost on that, I want you to jump on the YouTube channel, have a look at that area, and then we're going to go from there. Cool? Good luck.